Alright, so this is for section 3.4, which we are going to be talking about the product and the quotient rule. So before we get started, go ahead and recall that we have the power rule, which says that if we take the derivative of something to the form x to the n, that equals n times x to the n minus 1. The derivative of a constant b is 0, and the derivative of e to the x is just e to the x. So the question we want to ask is, if I have two functions and I'm multiplying them together and then I take the derivative, is that the same thing as taking the derivative of each piece and multiplying those derivatives together? Well, let's take a look. So if I work on the inside of this guy first, well, I can put x squared and x to the third together and get x to the fifth. You need to take the derivative of that guy. And the derivative of x to the fifth, well, using this rule, I know that's going to be 5x to the fourth. Now what we want to do is we want to see, is this equal to taking the derivative of each piece and multiplying them together? So the derivative of x squared, that's going to give us 2x, times the derivative of x to the third, which is 3x squared. Now if we multiply these two together, we are going to get 6x to the third. And these two things are not equal. So what we just discovered is that taking the derivative of two functions being multiplied together is not going to be the same as taking the derivative of each piece and multiplying those together. So how are we going to take the derivative of two functions being multiplied together? Well, that's where the product rule comes into play. So here we have the product rule stated. So if we have two functions, f of x and g of x, and we're multiplying them together and we want to take the derivative, what we're going to do is we're going to take the derivative of the first function multiplied by the second function left alone plus the first function left alone times the derivative of the second function. You can also think of this using prime notation. I wrote both here just in case you wanted to see that. So let's take a look at the derivative of x squared times x to the third prime. So I know that I can just multiply these together and find the derivative, and I know that I should get 5x to the fourth. But let's try it using the product rule and prove to ourselves that we're going to get the same answer. So using the product rule, I have x squared times x to the third. I want to take the derivative of this. So I'm going to let x squared, I'm going to let that be my f, and I'm going to let x cubed, I'm going to let that be my g. So the product rule says that I need to take the derivative of f, which is 2x, and multiply that by g left alone. That's just going to be x to the third. Then I need to add to that my f function left alone times the derivative of my g function, which is going to be 3x squared. So here we have f prime, here we have g left alone, here we have f left alone times g prime. So let's see, that's going to give me 2x to the fourth plus, this is going to be 3x to the fourth, which if I add together, I will have 5x to the fourth, which is exactly what we wanted. Great. All right, go ahead, pause the video and try this example on your own, and then when you're done, unpause and we'll do it together. All right, so let's try to evaluate the derivative of this guy. So I can't just put these together like I can these two. So since they don't have the same base, I can't just put them together and do something with their exponents. So if I want to take the derivative, well, the first thing I'm going to do is I'm going to rewrite the square root of x as x to the 1/2 times e to the x. Want to find the derivative? I'm going to let this be my f, and I'm going to let this be my g. So by the product rule, I'm going to have the derivative of f, which is 1/2 x to the negative 1/2 times g left alone plus f left alone times the derivative of g. Well, the derivative of e to the x, remember, is just e to the x. We'll just have e to the x. And this would be our solution. You can also pull the e to the x out and write this as e to the x times 1/2 x to the negative 1/2 plus x to the 1/2. Either way is fine. Alright, let's look at one more example. Let's say that we want to evaluate the square root of x times e to the x times x to the third. So what I could do is that I could just put this square root of x and this x to the third together, but I want to illustrate how do we use the product rule if we have three terms. So to do this, I'm going to call this term f, and I'm going to call this term g. So to use the product rule, I know that f equals the square root of x, and I know that f prime equals 1/2 x to the negative 1/2. And here, I know g equals e to the x, x to the third, and g prime is going to equal the derivative of the first times the second left alone, plus the derivative of the second one times the first left alone. So if I want to find the derivative of this guy, which is f times g prime, it's going to be the derivative of f times g left alone plus f left alone, which I'll write as x to the 1/2, times the derivative of g, which is going to be this whole guy. So that'll be e to the x, x to the third, plus e to the x, 3x squared. And now let's just clean this up a little bit. So that's going to be 1/2. So let's see, if I take x to the negative 1/2, multiply by x to the third, I'm going to get e to the x, and that will be x to the, let's see, that's the same thing as 6 over 2, so that would be 5/2. Plus, and if I take this x to the 1/2 and multiply it through, I'm going to get e to the x times x to the 7/2 plus 3 e to the x, x to the, so if I take 2, it's going to be 5/2. Now notice in every term I have an e to the x, and I also have an x to the 5/2. So I can pull those guys out, and I will end up with e to the x times x to the 5/2. So that would leave me with a 1/2 in this term, plus, if I pull out an x to the 5/2 here, I will end up with just an x, plus, and here I will just end up with a 3. So that will give me e to the x, x to the 5 over 2, times x plus 7/2 would be my answer. Go ahead and try to find the derivative of this guy if we were actually to put these two terms together. So that would be the derivative of e to the x times x to the 7/2, and make sure that you get the same number. Alright, let's do it together. So that's going to be the derivative of the first times the second one left alone, plus the first one left alone times the derivative of the second, which would be 7/2 times x to the, so if I subtract 1 from this exponent, I'm going to get 5 over 2, which again, I have an e to the x in both of these terms, and I have a x to the 5/2, so if I pull those out, I'm going to be left with here, I will have an x, and here I will have 7/2 left over. Great, so that's it for the product rule. Next we're going to talk about the quotient rule. So the quotient rule is when you have an f of x and a g of x, and you're dividing the two functions. So if we want to find the derivative of f of x divided by g of x, what we are going to do is we are going to do the bottom times the derivative of the top. minus the top times the derivative of the bottom, all over the bottom squared. I don't know why that song helps me remember this, but it does. All right, we also have it written down here in prime notation. By the way, the order in which you take these derivatives is important. So you do want the bottom times the derivative of the top, minus the top times the derivative of the bottom. So try not to get those mixed up. All right, let's see this in action. So let's say that we want to evaluate x squared minus 1 divided by e to the x. So if I want to take the derivative of x squared minus 1 over e to the x, well, my f is going to be x squared minus 1. My g is going to be e to the x. My f prime is going to be 2x, because remember, the derivative of a constant is 0. The derivative of e to the x, well, that's just going to be e to the x. So the derivative of this function, prime, is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now let's see if we can simplify this. So I have an e to the x here and an e to the x here. So I can pull those guys out and I'll be left with 2x minus x squared minus 1 divided by e to the x squared. I have an e to the x here and I have 2 of them down here, so I can cancel one of these. And I will be left with, let's see, I can also pull a negative out of there. That'd be x squared minus 2x plus 1 divided by e to the x. So let's see. So I know two numbers that multiply to positive 1 and add together to negative 2. I do. They are negative 1 over e to the x. So that would be our final solution. All right, cool. Let's take a look at some more stuff. So before I move on to doing this problem, I just want to note that from the product rule, we get a whole new derivative rule, which says that if I take the derivative of e to the kx, so k is just some number, then that's going to equal k times e to the kx. Or if you want to write that in prime notation, e to the kx equals k times e to the kx. Same thing. So let's use that to evaluate this derivative. Boop. So if I want to take the derivative of e to the 3x divided by x squared plus 2, go ahead and try this on your own. So pause the video, try it on your own, and then check back and let's see how we did. All right, so using the quotient rule, this is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Alright, so remember that the derivative of e to the 3x, since we have that constant in there, the derivative of the top is going to be 3e to the 3x by this rule. Also, x squared plus 2, the derivative of that guy is going to be 2x, since the derivative of 2 is 0. Alright, let's see if we can clean this up at all. So I have a e to the 3x here and an e to the 3x here, so I can pull it out. E to the 3x times, so let's see, I'm left over with a 3 here. If I distributed that, I would have 3x squared plus 6 minus 2x divided by x squared plus 2 squared. So this actually doesn't factor, and I can't cancel this out with anything down here, so we would be left with this as our final answer.